The topic for today is proportionality shown in tables. The essential question is, how can you tell if two quantities have a proportional relationship in a table? So we'll start off with the definition of proportionality. So proportionality, that's when two quantities are proportional if they have the same size in relation to one another. Okay? So let's dive right into an example. 1 pound of roast beef costs $8. Use this information to complete the table below. So I see I have a table right here. So the first thing I've taught you to do is just to label your X column and your Y column. Okay? And we need to fill out the table based on this information. So let's see right here. If they bought 0 pounds of roast beef, then that wouldn't cost anything. If they bought 1 pound of roast beef, that cost $8. So if I had half of a pound of roast beef, I would have to cut that in half and get the 4. Okay, because 1 pound cost $8, so half a pound would cost $4. 2 pounds of roast beef would cost $16 because I just doubled that. Okay? Then when you start dealing with the half units, it might get a little bit more tricky. So I want you to recognize that this right here is a proportional relationship because they have the same size in relation to another. So for example, if I had doubled this right here, so if I went 1 to 2, I had to double this too, also 8 to 16, okay? If I cut this 1 in half to get half, I would also have to cut this 8 in half to get 4, all right? So I know right there that that's the unit rate. That relationship shows the unit rate. And if you're still not quite sure, you can always definitely do that y divided by x, okay? So I'm going to take this and go y divided by x. The y value is $8 for 1 pound of roast beef. Right up here, again, y divided by x. The cost is $4 for half of a pound. So that's not the unit rate because I have to have 1 in the denominator. So how do I get from 1/2 to 1 using multiplication or division? Well, 1/2 divided by 1/2 is 1. Okay, so I have to go 4 divided by 1/2. And if you're like, well, how did she get 8? Let me go ahead and show you off to the side. Okay, 4 divided by 1/2. Okay, so you're dividing by a fraction, so you got to do that keep, change, flip thing that you learned in the past. Keep it, change it, flip it. Okay, I'm going to do the fraction equivalent of 4 just to make it look easier for you, hopefully, more straightforward. 4 times 2 is 8, 1 times 1 is 1, okay? So 4 divided by 1/2 is 8, not 2. 4 divided by 2 is 2, but 4 divided by 1/2 is 8, okay? So we also get $8 for 1 pound. Okay, and same with this situation right here, y divided by x to find your unit rate. So $16 for 2 pounds. That's not the unit rate because you want 1 in the denominator. 1 pound. So I got to go 2 to get, how did I go from 2 to 1 using multiplication or division? Well, I divided by 2. So I got to divide the numerator by 2, and 16 divided by 2 is 8. $8 per pound, okay? So since we know that that's the unit rate, there's something I want you to do in your table. I want you to show that all the values of x in this column times 8 give you the corresponding y value. So 1/2 times 8 gives you 4. 1/2 as a decimal is 0.5, okay? 0.5 times 8 does give you 4. 1 times 8 gives you 8. 2 times 8 gives you 16. So I'm going to continue that pattern all the way down so I can figure out those other values, okay? You notice I skipped this right here because if I was trying to find the unit rate by going 0 divided by 0, that's not going to work because you can't divide by 0. 0 divided by 0, see it says error. It's undefined. We can't do that. So typically when I'm finding the unit rate, I always just skip the 0, 0 relationship right there and I go straight for the numbers, the other numbers that aren't 0, okay? All right, so in order to get these other values, I need to go 2.5 times 8 to get this corresponding cost. So 2.5 as a decimal, in case you don't recall, I'll show you how to do it. 2.5 as a decimal. You know that 2 is the whole number, and 1 divided by 2 should give you 0.5. Okay, so it says 0.5, but there's already a 2 there representing this whole number, so it's 2.5, 2 and 5 tenths. Or another way you can do it is by turning your mixed number into an improper fraction by going 2 times 2, which is 4. 4 plus 1 is 5. Keep the same denominator, 5 halves, so 5 divided by 2 is 2.5. So right here I can go 2.5 times 8, and you get 20. Okay, go ahead and figure out the next couple of values right there, 3.5 times 8 and 5 times 8, okay? You should have gotten 28 and 40. So I want to know, do you notice any patterns in the table? Do you see any patterns here? Well, I see a pattern. I see that all we did was multiply the x value by 8 each time to get the y value. Because even it works up here, look, 0 times 8 is 0. So you multiply the x value by 8, which is the unit rate. That says unit rate. Each time to get the corresponding, so corresponding means like they go together, like they match, okay? So it wouldn't be like, oh, this times 8 to get this. No, it's like straight across, okay? To get the corresponding y value. Okay, and there's also something I really want to show you, okay? And we're going to write about it, okay? So you'll see I drew a box around this right here, and that identifies my unit rate. So I do want you to write this down in case you haven't noticed it. So please write this down. And I left room right up here for that. And this is important. In a proportional table, when the x value is 1, the corresponding y value is the unit rate. So take a second and write that down and then read what you wrote so it makes sense. That's the corresponding y value is the unit rate. Okay, so look. So in a proportional table, here's a proportional table. I know it's proportional because it's got the same unit rate going down right here. We're multiplying x by the same number every single time to get the corresponding y value. And when I find the x value as 1, its corresponding y value is the unit rate. So if you're going down the line and you're like, oh, it's proportional. Oh, wow, there's a 1 right there. So that corresponding y value that goes with the 1 with the x is going to be the unit rate, okay? So that's a nice little trick. So if I ever asked you in the future, hey, what's the ordered pair for the unit rate? You would go 1, 8. That's the ordered pair for the unit rate, okay? For this particular example, okay? All right, what's the constant proportionality? Remember, constant proportionality is just a fancy word for unit rate. So, well, what was it? It was, if you forgot, you could just go y divided by x. And since it's a proportional table, I can really take any value I want right here and it'll equal the unit rate. So I can go 40 divided by 5, boom, that's 8. 28 divided by 3.5, boom, that's 8. But I'm just going to use this right here, $8 for 1 pound. That's the unit rate. Okay, folks, let's write down the summary. When you're able to multiply the first column by the unit rate each time, that means the two items you're comparing are proportional. So when you're able to multiply the first column by the unit rate, so when you take this first column multiplied by the unit rate each time to get that corresponding y value, that means that those two items you're comparing are proportional. Now, if you can't multiply by the same number every single time, then the two items being compared are not proportional. So what I mean by that is, we know this is proportional because it's times 8, times 8, times 8, times 8, times 8, times 8. If for some reason you had all times 8 and then down here you had times 5, double check your work to make sure you didn't mess up. But if there's one that's random oddball, then that would not be a proportional relationship, okay? The next problem shows a table, and it's a horizontal table. And the first thing I'm going to go ahead and do is label that X and Y, okay? All right, and it says that for every hour worked, you get $7. Complete the table above. So I can kind of tell that this is already going to be a proportional relationship simply because I'm noticing a pattern between the X and Y values that are already given, these two right here. And when I double check that, for all the values that are given, I'm going to go Y divided by X, and I see that Y is $7 for 1 hour worked, and I see that there's a 1 on the denominator, so I know that right there is the unit rate. The other value that has, or the other relationship where the X and Y are given, do the same thing. So Y divided by X, and you get $14 for working 2 hours. That's not the unit rate because we got to divide by 2 to get 1 in the denominator. So 1 hour, for working 1 hour, you get, yes, 14 divided by 2, $7 an hour, okay? So that's obviously the unit rate. Also from the first page, I had you write something down right there, and I already just recopied it over here. In a proportional table, when the X value is 1, the corresponding Y value is the unit rate. So I see that right here. Okay, that right there is the unit rate, that 7. So that ordered pair shows us the relationship for the unit rate. So if I ever asked you, and if I give you like a proportional table and I say, hey, what ordered pair displays the unit rate, you would just say, put it in parentheses and put 1, 7 in parentheses, okay? That would imply that right there, that relationship is the unit rate. All right, since the number of hours worked and the amount paid are proportional, find the following information. Oh, and it's also telling us it's proportional. That's nice. What's the constant proportionality? Well, it just as asking what's the unit rate, which we've already established right up there. You just went Y divided by X, and you could just pick one of the given values. Instead of doing 1 and 7, I'm going to do 2 and 4. So, 14. So that 14 is the pays on top. Numerator, hours worked for 2 hours. That's not the unit rate. Got to divide by 2 to get its equivalent fraction. 14 divided by 2 is $7. 2 divided by 2 is 1 hour. See how 1's in the denominator? That's the unit rate, so right there. You make $7 an hour in this table. That's the unit rate. So if a person was paid $84, how many hours did they work? So let's see if it's in the table. If they were paid $84, I don't see $84. It could be one of these. So it might be one of these hours right here. So we better fill in these values before we really get going on this, okay? So something that I want you to do to help you fill out tables is remember how I want you to write times the unit rate right there. So times 7, 1 times 7 is 7, and because that unit rate's 7, 2 times 7 is 14. So I gotta times this value by 7 to get this one, times 7, times 7, times 7. All those X values have to be times multiplied by 7. Oh, and looks like there's some blanks right there. So timesing by 7, timesing by 7, okay? So 4.5 times 7, go ahead and figure that out. 4.5 times 7. You can do 4.5 times 7. And you get $31.50. So if you work 4.5 hours, you get $31.50. 5 times 7 is 35. 6 times 7 is 42. Ooh, what's 6.5 times 7? Go ahead and figure that one out. Okay, it's $45.50. I'm just gonna put 45.5, same thing, just because there's not enough room. And then all this right here is blank. So you'll see that I don't have the value for this. If a person was paid $84, how many hours did they work? I don't see any $84 right there. So since there's blanks right there, that was my hint to you that, hey, you're gonna put that right there, okay? So I'm gonna go ahead and put in, what did it say, $84. So you can figure out the corresponding hours worked. So Normally you would take this x value and times it by 7 to get the y value, but I gave you the y value, so you got to work backwards. So what's the inverse operation of multiplying by 7? It's dividing by 7. So what you'll do is you go 84 divided by 7. You get 12 hours. You'd work for 12 hours. Okay? You work 12 hours to make $84. And that's kind of interesting right here because since this is a proportional table, if I work 6 hours, I made 42 bucks. So if I doubled this 6 to get to 12, I'd have to double this 42 to get to 84. Oh, that makes sense. Well, I hope. Okay, so they would they'd have to work for 12 hours to make $84. All right, how much would a person be paid if they worked for 70 hours? So do I have 70 hours in the chair? Oh, I didn't do this one. That could be 70 hours, do you think? I don't know. All right, figure it out. So 21, got to go backwards. 21 divided by 7 gives you 3, so that's totally not it. Okay, back to this, sorry. How much would a person be paid if they work for 70 hours? I'm looking in the hours, I don't see a 70, so let's go ahead and put that 70 right there, please. Okay, so remember, you're multiplying that x value by 7 to get the corresponding y value. So 70 times 7 is 490. Okay. So how much would a person be paid if they work for 70 hours? They'd be paid $490 for working 70 hours. All right. And I've shown you in the past how to create an equation for this relationship right here. So I want you to go ahead and off to the left-hand side, go ahead and write an equation to display this relationship, please. So the equation for this would be y equals unit rate times x. Or you can say 7x equals y, or you can say x times 7 equals y, or you can say y equals x times 7, same thing, but typically you're going to see it like in this form right here, where they have the dependent variable listed first and then the independent variable listed over here, along with that unit rate, okay? So I'm going to label that, that's the unit rate. X stands for hours, y stands for pay. So if you're wondering why I just had you do that, like I kind of read this really fast and then I looked up here, well, this is why. It says use H to represent hours worked and P to represent pay in dollars. Write an equation to represent the relationship. So you see this equation right here? I know I told you to use X and Y because that's how I'm training you to do this, but based on this knowledge, I'm going to show you how to use different variables, okay? So you should already have everything labeled as X and Y because that's going to help you. That's why I'm making you do that, okay? But they want you to use H to represent hours worked. So go back up to your table. Hours worked, they want you to use the letter H. And then also it says P needs to represent pay in dollars. So let's go back up here, look at where it says pay, and we're going to put up the letter P. Okay? So you see I have an H and a P right there? All you got to do is see where it said the letter X, I want you to put an H there. See where it said the letter P? That corresponds with the Y right there? Instead of the Y, you're going to put a P. Okay, so your equation is P for pay equals 7 times H, which is hours. So now let's go back down here and write our answer right there. Copy it down. So P equals 7 times H. Or obviously you can switch it around and go 7 times H equals P. Okay? And yep, P stands for pay in dollars. H stands for hours worked. Okay? All right, now it says, what does 2, 14 mean? Well, that has to do with this table, okay? So let's look for 214. There it is right there. And I see that the 2 corresponds with hours. The 14 corresponds with pay. So what that means is this. Remember, it's X and then Y. X stood for hours, so if you work 2 hours, you get paid $14. Okay? What does 535 mean? Well, let's look up here. Well, X and Y, and let's go look at the table. 535, that would be this ordered pair right here. So 5 hours worked, and you get $35. So basically, for every 5 hours you work, you get $35. Okay? Or you can also say if you work 5 hours, you get $35. This one up here, for every 2 hours worked, you get paid $14. Okay? All right, next problem, turn the page. These problems want you to use what you know about proportional relationships to determine if the following relationships are proportional. So I'm giving you some tables here, and their values are already all filled into them. And I just need you to determine, hey, is this relationship displayed in the table, is it proportional or not proportional? Just a reminder, for a table to be proportional, you must be able to multiply all of those X values by the same number every single time to get its corresponding Y value. It's got to have the exact same unit rate throughout the entire table, okay? All right, so the first situation says, number 1, you were hired to babysit. The table shows how much you'll be paid based on the hours you worked. And it's nice right here because it's already labeled X and Y for you. So if you work 1 hour, you make $8. If you work 3 hours, you get $24. If you work 4.5 hours, you get $36, and so on and so forth. And my first instinct is, hey, that's the unit rate. But remember, we don't know if this table is proportional or not because I already told you that. It might not be. So what you need to do for each one of these values is you need to go Y divided by X to see the unit rate. Now you'll see there's no room because I usually want you to write the Y divided by X right underneath it. But now that we've had more practice with this stuff, I don't mind if you just type it in your calculator or do it mentally right now, okay, for each one. So Y divided by X, 8 divided by 1 is 8. So I multiplied this X value times 8 to get the corresponding Y value. Okay, let's go Y divided by X. 24 divided by 3, well, that's also 8. So we're going to multiply that X value by 8 to get the corresponding Y value. Now 36 divided by 4.5. I don't really know that off the top of my head quickly, so I'm going to go ahead and type that in my calculator. I'm going to type in my calculator 36 divided by 4.5. Okay, 4 and 5 tenths. 36 divided by 4 and 5 tenths. Now I also get 8. So 4.5 times 8 is 36. All right, 52, Y divided by X, 52 divided by 6.5, what's that? It's also 8. So multiply by 8. 160 divided by 20. 160 divided by 20 is also 8. Just, double check it. Oops. And type it in correctly in your calculator. Yep, that's also 8. And then 168 divided by 21. Oh, it's also 8. So based on that information, we have a consistent unit rate for all the values in the table. So therefore, yeah, this is a proportional relationship, okay? So is your pay proportional to hours worked? Yes. There's a consistent unit rate. Now again, if they were all times 8 and then there was like an oddball that was like times 2 or whatever, double check to make sure you didn't mess up. But if there is one oddball, that would not be a proportional relationship, okay? So it says, what's the constant proportionality? Well, remember what I made you write on the side on the previous page? In a proportional table, when the X value is 1, the corresponding Y value is the unit rate. So that's another way you can figure that out. Well, you know this table is proportional, so I can see right here the X value is 1. That right there is the unit rate, that 8, okay? So you can also go Y divided by X, and you can pick pretty much any value in the table because we know that it's a consistent unit rate. We just did Y divided by X for every single one of them. So it's $8 per hour. That's constant proportionality, also known as unit rate. Okay, using x and a y, write an equation to show the relationship between hours worked and pay. So again, see, it's x and y. It's already labeled. Let's go ahead and write, okay, y equals unit rate times x. Okay, so y equals the unit rate, which is 8, times x. So x stood for hours worked. Y stands for the pay in dollars. Okay? And again, you can reverse that and go 8x equals y. But typically that's how you're going to see it, okay? All right. The next problem, number 2, says, does this table show a proportional relationship? And again, you're going to follow the exact same thing. Label x and y. It's already labeled. Go y divided by x to find the unit rate, okay? Just to see. Make sure it's consistent. It's consistent. So y divided by x. So I have to go 5 divided by 10. Not 10 divided by 5. It's y divided by x. So 5 divided by 10. Oh, 5 tenths. So I multiplied 10 times 5 tenths to get 5. So if you're like, what? How did that happen? Look, 10 times 0.5 is 5. All right, let's go 4 divided by 8. Y divided by x. Oh, that's also 5 tenths. And you do have to do it for every single value in the table, because what if the very last one was the oddball? Okay, if there was an oddball. 8 divided by 16, because it's y divided by x. Oh, it's also 5 tenths. And 10 divided by 20, also 5 tenths. So based on that information, does this table show a proportional relationship? Yes, because there's a consistent unit rate for all the values in the table. So what is that constant ratio? Remember, constant ratio is another name for unit rate, which is another name for constant proportionality. You might see this sometimes. What's the constant ratio? Well, it was, okay, remember, y divided by x. So let's see, I'm just going to pick one of the ones in the table, $5 per 10 pounds of candy. So that's not the unit rate because I want 1 in the denominator. So I had to divide by 10, divide by 10. 5 divided by 10 is 5 tenths. And that is the total cost. So basically 50 cents per pound, okay? So if you're like, well, how come it was so easy in this one to just find it right there? Well, it's because we had x as 1 and we found it right away. Do you see x as 1 over here? Nope. But if I put it right here, then I know I'd have to multiply it by 5 tenths. 1 times 5 tenths is 0.5. Or 5 tenths, same thing. Okay, using x and y, write an equation to represent this relationship. Here's x and y. Remember, it's y equals your unit rate times x. So the unit rate was 5 tenths. Or you could put 1/2, same thing. 5 tenths and 1/2 is the same thing. Or you can do 0.50 or 0.50000. That's all 1/2. Y stood for the cost, the total cost. X stood for the pounds of candy. Okay. And it says, what does 8 4 mean? Like in the story problem. So x is 8, y is 4, because that's ordered pairs. X stood for pounds, so 8 pounds cost $4. Or for every 8 pounds of candy you buy, it'll cost you $4. That says it'll cost $4. Okay, so look right here, 8 pounds of candy costs $4. What about 8 more pounds of candy? So that'd be 16 pounds of candy. Didn't it cost $4 more? Yep. Okay. So what's the ordered pair for the unit rate? So remember how we're like, oh, there's no one right there. Oh, there's a 1 right there. So this right here is the unit rate, the ordered pair for the unit rate. Remember, when x is 1, the corresponding y value is the unit rate, but it's asking for the ordered pair. So it'd be 1, 0.5, 5 tenths. Or you could say 1, 1/2. Because that's the same exact thing. Okay, you can't switch the order on those because you want x first and then y. Like you've been plotting ordered pairs for a while now. You should know that. Okay, turn the page. Number 3 says, this table shows the relationship of the amount of snowfall in 5 countries to the amount of time of a recent snowstorm. Is snowfall proportional to time? So it's giving you all the values in the table, and you got to figure out, hey, is it a proportional relationship? So remember, to find the unit rate, it's y divided by x, okay? So that's what you need to do. So here's x, here's y. It's already labeled for you, and if it wasn't, you would totally do that yourself, okay? So I got to go y divided by x. Now make sure you do it for every single one of the values in the table, because if you don't start doing that, if you don't continue to do that, then I'm going to start making you do that again, okay? So like write it out. You know how I used to make you write it all out every time, but now I kind of trust you. 10 divided by 2. Well, what's that? What's 10 divided by 2? If you don't know, get your calculator out. It's 5. Okay. So I went y divided by x times 5. So I took x times 5 to get 10. Okay. Again, y divided by x. 12 divided by 6. You don't know that? Do it in your calculator. And that is, what is that? Well, that's times 2, isn't it? Huh. Okay, 18 divided by 9, well, that's 2, so 9 times 2 is 18. Double check, so 2 times 5 is 10, 6 times 2 is 12, 9 times 2 is 18. Okay, 20 divided by 7, I don't know that. Oh, let's round to the nearest hundredth, so round that to the nearest hundredth, and you'd get 2 and 86 hundredths. Okay, and then 6 divided by 3 is 2, so 3 times 2 is 6. Okay. Does this table show a proportional relationship? No. There's no consistent unit rate. It's not consistent. So the next part of the question says, what's the unit rate? Well, you're going to notice right here that in the table, since it's not proportional, there's no unit rate. So that's what I want you to write. What's the unit rate? It's not proportional, so there's no unit rate. Okay, so using x and y, write an equation to represent this relationship. So you know how you normally go y equals unit rate times x? Well, since there's no unit rate, it's not consistent, you can't write an equation based on that, okay? So you can't. The data isn't consistent. So the information in the table is not consistent. Okay. So number 4. It asks, does this table display a proportional relationship? So again, what you do, you label x and y, and it's already labeled. Find the unit rate for each value in here, and if they're not consistent, then it's not proportional. There's no unit rate. If it is consistent, then yes, it's proportional, and you could totally find the unit rate just from that, okay? So let's go ahead and remember y divided by x. Y divided by x is the unit rate. So 5 divided by 20. Go ahead and figure that out. It's y divided by x, and that is 25 hundredths. So we took this x value, multiplied it by 25 hundredths to get the corresponding y value. Took the x value times that to get this. Okay, now let's go 15 divided by 60. And I also got 25 hundredths. So far it's looking like it could be proportional. But remember, you have to check every single value in there to make sure there's no oddball. And I'm sorry, this looks kind of weird. That says times decimal 25 hundredths, okay? It should not look like a colon. I apologize. Okay, so 17 divided by 68. Y divided by x. Again, that's 25 hundredths, so I'm going to try my best to make it multiply by 25 hundredths. Okay, that looks a little better. Okay, 23 divided by 92. Y divided by x. 23 divided by 92 equals 25 hundredths. So we're going to multiply it by 25 hundredths. Okay? So I see right here that this is a proportional relationship. And it says, well, we got to answer that, so yes. Does the table display a proportional relationship? Yes. There's a unit rate. There's a consistent unit rate. Okay? And this is what's K. So if you're like, what the heck does K mean? I've told you that sometimes they have different ways to represent unit rate. And one of those ways is constant proportionality. One of those ways is constant ratio. And K is another one. In math, for whatever reason, they like to use the letter K to represent unit rate. So it's basically saying, what's the unit rate? Well, it's y divided by x We want to label it. So let's just pick any one of these values because we all know that this is a proportional table. So I can go 23 miles in 92 minutes. So that's not the unit rate. I gotta get 1 in the denominator. So 92, how do you get from 92 to 1 using multiplication or division? Well, we can divide it by 92. 92 divided by 92 is 1. So we gotta go 23 divided by 92, and we get, 25/100ths. So we get 1/4 of a mile per minute, or 25/100ths of a mile in 1 minute. So that right there is the unit rate, okay? Using x and y, write an equation to represent this relationship. Totally can, because this is a proportional relationship. So let's go. Y equals unit rate times x, okay? So this y value is equal to this unit rate times this x. Or you can switch that around. 25/100ths times x equals y, same thing. But I do want you to label it. What does x stand for? It's minutes. And what does y stand for? Miles. Okay? What is the unit rate's ordered pair? Okay, remember what I told you to write? In a proportional table, when the x value is 1, the corresponding y value is its unit rate. Well, I don't see a 1 right there, so what do? Draw it in. Now let's add to the table. So when x value is 1, the corresponding y value is the unit rate. So since we don't know what that y value is, you just follow the pattern. Oh, so we got to multiply it by 25/100ths. What's 1 times 25/100ths? Well, it's 25/100ths. Okay, so that right there is the unit rate. And so it wants to know the ordered pair for it though. So we want 1, 25/100ths. Or you know how you could also say it? 1, 1/4. Because 1 divided by 4 is 25/100ths. Same thing. They're interchangeable. But don't change the order of this, okay? You got x first and then y when you're listing order pairs. For your summary, how do you know when a table is not proportional? How do you know when a table is not proportional? This table was proportional. This table was not proportional. How did we know? Answer that question. Number 5 says, which table represents a proportional relationship between x and y? So, based on how it's worded in the question, there's only going to be one correct answer to this problem. Is it going to be A, B, or C? Because it's saying which table is representing a proportional relationship. And what you need to do to find if the table is proportional, you need to first find and see if there is a consistent unit rate for each of the values within the table. So remember, unit rate is y divided by x. So you're going to do y divided by x for every single relationship in each table. And the table that does have a proportional relationship will have a consistent unit rate. And that will be your answer, okay? So I'm going to go ahead and do this with you. But if at any time you're like, oh, I get this, I want you to try it on your own, okay? So y divided by x, and I'm going to go 1 divided by 2/9. So I see right here 2/9. I can make that a decimal. So 2/9 as a decimal. You got to go 2 divided by 9. Oh, and it's 0.2 repeating. Okay, so when you have something like that, when it's like a repeating decimal, to be more precise, I would prefer that you kept it in a fraction, okay? So I'm going to show you on this particular type of calculator how to keep that as a fraction. So I got to go 1 divided by 2/9, because 2/9 is more precise than 0.2222 repeating when you can type in your calculator, because your calculator, it doesn't go on forever, although this decimal goes on forever, okay? Hope that makes sense to you. So 1 divided by 2/9, so 1 divided by, now 2 is the numerator, and then see this button right here? You press that. That gives you this fraction bar. And if your calculator is different, it's going to look similar to this, where it looks like there's a mixed number, okay? So I'm going 1 divided by 2/9, so 9 was the denominator. And that is 4.5. So I took 2/9 and I multiplied it by 4 1/2, or 4.5, to get the y value. So I got to go 2 divided by 5/9. Let's see. 2 divided by 5/9. 2 divided by 5/9. So 5, fraction bar ninths equals, oh, 3 3/5. So I took this right here and I went times 3 3/5. So you're going to see right now, unless I messed up, that those are totally different. So I'm going to do this last one right here just to see maybe I messed up somewhere. 3 divided by 7 ninths. Fraction bar ninths. 3 6/7. So I multiplied x by 3 6/7 to get the y value. And you're going to see right now that this is not a consistent unit rate. So this right here is not my answer. All right, let's try B. Remember, y divided by x. So you can totally maybe do the decimal here. 5/8. What's 5/8 of the decimal? 5 divided by 8. Oh, that's not too bad. Okay, so I can type that in. All right, so I can go 2 divided by 625 thousandths. Just get that unit rate right there. 2 divided by 0.625. Oh, it's 3 2/10. So I took this x value, I multiplied it by 3 2/10. And if you're like, gosh, you know what, I like how Hopkins kept it as a fraction. Yeah, you can do the same thing, you get the same answer. 2 divided by 5/8. Look, 2 divided by 5 fraction bar 8 is 3 1/5. Is that the same as 3.2? 3 1/5 equals, well, 3 is a whole number. 1 divided by 5 is, oh, 0.2. Isn't that what we had gotten right here? Okay. So it's okay to be flexible with your numbers, all right? If you don't like the fraction, turn it into a decimal, but if it's one of those repeating decimals, I would totally keep it as a fraction, okay? All right, 4 divided by 1 1/8. I'm going to show you what that would look like on your calculator. 4 divided by 1 1/8 using the fraction bar. 4 divided by 1 fraction bar thing and 1 fraction bar thing, eighth, equals, oh, 3 5/9. Times 3 5/9. Was that the same thing over here? 3, no, that was 3 1/5. Okay, so 8 divided by 2 1/8. 8 divided by 2, fraction bar 1, fraction bar 8. 3 13/17. So I times this by 3 13/17. That says 13/17. Okay. And you see that it's not a consistent unit rate, so therefore that is not a proportional relationship in that table. Okay, for this one, I'm just going to go 1/4 divided by 1 1/2. I'm going to keep it all as fractions. 1 fraction bar 4th divided by 1 1/2. 1 fraction bar 1 1/2, like that. So it's 1/6. So I multiplied x times 1/6 to get the corresponding y value, because 1 1/2 times 1/6 is 1/4. So I'm going to go 1/2 divided by 3. So 1 fraction bar half divided by 3 equals 1/6. So far, so good for proportionality. 3/4 divided by 4 1/2. 3/4 divided by 4 1/2. Yep, 1/6. So this right here shows a proportional relationship. The answer is C. Okay, number 6. Select all tables that represent a proportional relationship between x and y. So this wording, see how it's different than this one? This wording implies, hey, there could be more than one answer, okay? So again, you gotta do y divided by x. So right here, 10 divided by 1/5. 10 divided by 1 fraction bar 5th is 50. So I multiplied x by 50 to get that y value. Y divided by x is 20 divided by 2/5. Okay, again, that's also 50. 30 divided by 3/5 is also 50. And you do want to make sure you do for every value in the table, just because, oops, times 50. Because what if the last one was an oddball and you skipped it because you were trying to rush through it. So this right here, that does show a proportional relationship. Okay, 1/8 divided by 1, because it's y divided by x. So y divided by x. 1/8 divided by 1. Well, that's 1/8. Actually, I can do that in my head, but 3/8 divided by 2. Oh, it's 3/16 times 3/16. Okay, 5/8 divided by 3. 5/24. So times 5/24. That's not 1. So nope. Okay, right here, 1 divided by 2/7 because it's y divided by x. 1 divided by 2 fraction bar 7 is 3.5. So I times by 3.5. 7 divided by 4/7 is 12.25. And then 14 divided by 6/7 is 16 1/3. So yeah, that's totally not proportional. So nope. Okay, this one, 1 divided by 1/4. Remember, it's y divided by x. So 1 divided by 1/4 is 4. 2 divided by half. Oh, is 4. 3 divided by 3/4. Whoops. 3 divided by 3/4 is 4. So yeah, this is also proportional. Okay, so there's 2 answers there. Now for your summary, finally, what is the most challenging part about determining if a table is proportional or not? So you see how you had to do all this? What was the most challenging part about that process? Answer it. Bye.